Here are the answers for the Section 3-5 homework, starting on page 98, oral. Tell how to combine the equations so that the indicated variable is eliminated. So here's number one. Our first equation is 3x minus 2y equals 7. The x term is a positive 3x. The y term is a negative 2y. The second equation is 5x plus y equals 3. The x term is 5x. The y term is positive 1y. Let's explain how we could eliminate the letter y by combining the equations together. To eliminate the y terms, they must be opposites of each other. This one is negative 2y. We would like this one to be positive 2y because a negative 2y plus a positive 2y makes 0 when you combine the two equations together. So the way that we're going to do this is to transform the second equation by multiplying all of the terms by 2. The equation will change into 10x plus 2y is equal to 6. Let's keep the first equation the same as it is to begin with. 3x minus 2y equals 7. When we combine them, the y terms will be eliminated. 3x add 10x is 13x. And 7 plus 6 is 13. For the oral exercises, we're not going to continue the process. We only wanted to show how to make the y terms opposites of each other. For number 3, we have two equations. We want to eliminate the variable a when we combine the equations together. So let's look at the a term. This one is 3a, but this one's only 1a. For the a terms to be eliminated, they have to be opposites of each other. The opposite of 3a is negative 3a. So let's transform the second equation by multiplying by negative 3. It becomes negative 3a plus 6b is equal to negative 12. Let's keep the first equation the same as it is. 3a plus 5b is equal to 7. Now when we combine them together, the a terms cancel away, and we have 11b is equal to negative 5. If we wanted to solve the system, we would continue this process and solve for b, and then use that answer to solve for a. But in the oral exercises, we were only asked how to make the a terms be opposites of each other. Number 13. Transform so that the indicated variable is expressed in terms of the other variable. We have the equation 2y equals 4x minus 6, and we want to solve it for y. We want to get the variable y alone. It looks like all we need to do is divide the coefficient of 2. So y is equal to 4x divided by 2 minus 6 divided by 2. This is equivalent to y equals 2x minus 3. Number 15, solve for m. Looks like all we need to do is add the n term to move it to the other side. We get m equals n. Number 17, solve for y. Let's subtract 4 from both sides. We get 2x minus 4 equals negative y. Then divide everything by negative 1. Negative 2x plus 4 is equal to positive y. We have solved for y. If it bothers you that the y is on the right side, then use the symmetric property to reverse the sides. Now page 99, the written. Let's solve the system. We're going to begin by deciding how to eliminate one of the variables, like we did in the oral exercises. It doesn't tell us which variable to try to eliminate, so that's our choice. Let's look at the terms and make a decision about which one would be the fastest to eliminate. Focus on the x terms. We have 1x and 5x. They're not opposites right now, but if you multiplied the first equation by negative 5, this would become negative 5x, which would be the opposite of 5x. Focus on the y terms. This is positive 1y, and this is negative 3y. Those are not opposites. But if you multiplied the first equation by 3, this would become 3y, which would be opposite of negative 3y. It sounds like it would take an equal amount of work to eliminate the x or to eliminate the y. So it's totally our choice which we choose to do. I'm going to choose to eliminate the x terms by multiplying the first equation by -5. It will transform into -5x minus 5y equals -25. For the second equation, I'm going to keep it the same. Now combine the two equations into one equation by adding the left sides together and adding the right sides together. The x terms cancel away. The y terms combine to -8y. On the right side, -25 add 17 is -8. Divide both sides by -8 and we get y is equal to 1. We have found the answer for y. We don't yet know the answer for x. Let's use that value of y and substitute it into one of our original equations to find the answer for x. It's our choice which one we substitute it into. Which equation looks easier to solve for x? The first equation or the second equation? Well, I think it's the first one because it doesn't have coefficients that we would have to multiply by. Where the letter y is, we're going to put our answer in 1. So we get x plus 1 is equal to 5. Therefore, x equals 4. As an ordered pair, our answer to the system is 4, 1, because you write the x-coordinate first and the y-coordinate second in the parentheses. This is the solution to the system. 4, 1 solves the first equation and it solves the second equation. Do you believe it? 4 plus 1 equals 5. That checks out. If you put in 4 and a 1 in the second equation, it also checks out and makes 17. We're asked to illustrate this with a graph, so we need an x and y axis grid. Let's graph the first equation, which is x plus y equals 5. One way to graph that equation is by finding its intercepts. When y is 0, the x has to be 5. So the x-intercept is 5. 1, 2, 3, 4, 5. Now let's find the y-intercept. When x is 0, the y has to be 5. So the y-intercept is 5. 1, 2, 3, 4, 5. The first equation has this diagonal line as its graph. Now let's graph this second equation. We can find its graph by finding its intercepts. If we fill in 0 for y, we get 5x is equal to 17. And when you divide both sides by 5, we get 17/5. As a mixed number, this is 3 2/5. So on the x-axis, here's 3 and an extra 2/5. Now let's take that equation and fill in the 0 for the letter x. So it would become -3y is equal to 17. When you divide both sides by -3, you get -17/3. As a mixed number, this is -5 2/3. So on the y-axis, let's find that spot. 1, 2, 3, 4, 5, 6 marks. -5 2/3 would be in between that -5 and -6 mark. Let's draw a line through those two dots. This line is the graph of the second equation. Now, notice where they cross each other. This dot is the intersection of the lines and the solution of the system. It's 1, 2, 3, 4 to the right and 1 up, 4, 1. That corresponds to our algebraic solution. Next, number 3. Let's solve this system. I'm going to solve this system with a different method than what we used in number 1. In number 1, we combined the equations together so that one of the variables was eliminated. That technique was called linear combination method. This time, I'm going to use substitution method. And the reason for doing that is that one of the equations tells us that the variable u is equal to the variable v. That means we can substitute a v in place of a u. We're going to take the v and substitute it where the letter u is in the other equation. That creates 4v equals 2v minus 6. Now we can solve this equation for v. Subtract 2v from both sides, we get 2v equals negative 6. And divide by 2, we get v equals negative 3. We're halfway done. Now we need to find the solution for u. Take the answer for v and substitute it into that first equation. And it will say u equals negative 3. So now we know the answer for u. As an ordered pair, u is negative 3 and v is negative 3. We're supposed to create a graph to illustrate that. Let's make this the u-axis and this the v-axis. And graph the first equation, u equals v. One solution is 0, 0. Another solution is 1, 1, 2, 2, and so on. This diagonal line is the graph of the equation u equals v. Our other equation was 4u equals 2v minus 6. Let's locate the intercepts by filling in the zeros. We can fill in a 0 for the letter v. This will become 4u equals negative 6. When you divide both sides by 4, you get negative 6 over 4, which reduces to negative 1.5. So on the u-axis at negative 1.5, there's a dot. Now let's fill in 0 for the letter u. Our equation will become 0 equals 2v minus 6. From this we can get v equals 3. So the v-intercept is at positive 3. And we can draw the line through the dots. These lines intersect at this point. And this is located left 3, down 3. Next, number 5, let's solve this system. Which would be the faster technique? The combination method, where one of the variables is eliminated, or the substitution method? This time I think combination, because when I look at the terms, the y terms are already opposites of each other. We can combine these equations together. X plus x is 2x. 10 plus 8 is 18. Therefore, x equals 9. Choose one of the original equations and substitute the value for x. We get 9 plus y equals 10. Therefore, y equals 1. Our solution is 9, 1. Now let's graph that. The first equation has an x-intercept at positive 10, and it has a y-intercept at positive 10. This line is the graph of the first equation. Now let's look at the equation x minus y is equal to 8. When y is 0, the x is equal to 8. So there's a dot at 8 on the x-axis. When x is 0, this becomes negative y is equal to 8, or y equals negative 8. So let me extend the y-axis and put 8 marks going down. Here's the y-intercept. The intersection of the lines is the solution to the system. That dot is 9, 1. Next, number 7. We need to make a decision about what technique is the fastest way to solve the system. Should we try to eliminate variables when we combine, or should we solve for one of the variables in terms of the other and substitute? It's our choice which we do. I'm going to use elimination method. When I look at the r terms, this is 1r, the other one's 2r. The opposite of 2r is negative 2r. So let's make the first equation have a negative 2r. We need to times by negative 2. It transforms into negative 2r plus 16s equals negative 22. The second equation will keep the same. And now add the sides together. On the left side, both variable terms cancel out, creating 0. On the right side, both terms cancel out, making 0. We get a true statement. What that tells us is any solutions to the first equation will also work in the second equation. There was a vocabulary word given to these kind of systems in the section. The equations were dependent. All solutions of one equation are also solutions to the other. Let's illustrate this with a graph. Here's the r-axis, here's the s-axis. Let's first graph r minus 8s equals 11. When s is 0, r equals 11. Here is the r-intercept. Now let's put 0 for r. We get negative 8s equals 11. So s is equal to negative 11 over 8, which is negative 1 and 3/8. That's located in between the negative 1 and negative 2 marks. This line represents that first equation. Let me switch colors and graph the second equation. 2r minus 16s is equal to 22. When we put 0 for s, this becomes 2r equals 22, or r equals 11. That's the same dot we had found on our first graph. When we fill in 0 for r, we get negative 16s is equal to 22. Divide both sides by negative 16 and we get negative 22 over 16, which reduces to negative 1 and 3/8. That's the same dot we had on our other graph. When we draw through them, notice that this line is overlapping the first line. These lines coincide. All solutions to one of them are also solutions to the other one. Next, number 9. Let's solve this one by combination method, where we eliminate one of the variables. Which variable should we eliminate? If we want to eliminate the a term, we could leave this one as 6a and transform this into negative 6a. But if we wanted to eliminate the b term, we could leave this one as negative 5b and transform this into positive 5b. It sounds like it's an equal amount of work either way. I'm going to choose to eliminate the a term. So I'm going to multiply the first equation by negative 3. That creates negative 6a. And then minus 3b is equal to 6. And keep the second equation the same. Now when we combine these by adding, the a terms are eliminated. This is negative 8b is equal to 24. Therefore, b equals negative 3. We're halfway done. We have the answer for b. Let's substitute that into one of the original equations. In your opinion, what equation does it look like it's faster to substitute in the b? Here or down here? I think it's the first one, because there's no coefficient that we would multiply by it. This will create 2a plus negative 3 is equal to negative 2. Let's solve this for a. First, add 3 to both sides. 2a is equal to 1. Then divide by 2. We get a equals a half. Our solution is 1/2 comma negative 3. Let's graph that. This is the a-axis and this is the b-axis. Focus on the first equation. 2a plus b is equal to negative 2. Let's find the intercepts. When we use a 0 for b, this becomes 2a equals negative 2. Divide both sides by 2 and you get a equals negative 1. That's located here. When you use 0 for a, this becomes b equals negative 2. and that's located right here. Here's the line through those dots. Now let's look at the second equation and graph that one. The second equation is 6a minus 5b is equal to 18. When we use a 0 for b, this becomes 6a equals 18. Therefore, a equals 3. That's located here. When we use a 0 for a, this becomes negative 5b equals 18. Now divide both sides by negative 5. We get negative 18 over 5. As a mixed number, this is negative 3 3/5. 1, 2, 3, and then an extra 3/5. And draw through those two dots. The intersection of the lines is the solution to the system. That appears to be about right there, and that is over a half and down negative 3. Number 21. Let's solve this for x and y. This simply means solve the system. It looks like the combination method is the best way to go because the y terms are already opposites of each other. X plus x is 2x, and 3a and 2a is 5a. So x is equal to 5/2 a. Let's substitute that in place of the letter x in the first equation. 5/2 a minus y is equal to 3a. I'm going to multiply everything by 2 to remove the fraction. 5a minus 2y is equal to 6a. Now subtract 5a from both sides. Negative 2y is equal to a. And divide by negative 2. Y is equal to a divided by negative 2, which is better known as negative 1/2 a. We have solved for x, and we have solved for y. The review assignment is on page 94. We're given some information about a line and asked to draw the line, then get its equation. What we're given is a point that's on the line and the slope of the line. From that, we can graph the line. You start by graphing the point. So negative 1, 2 is located here. Then use the slope as rise over run to get another dot. If the slope is 3, that is the ratio 3 over 1. The top number is rise, the bottom number is run. So let's put some more marks on there so that we can measure that off. From this dot, rise 3 and run 1 to the right. This is the line that fits that information. Now we want to get its equation. When you're given a point and the slope, we need to use point-slope form. The formula for that is y minus y1 equals m parenthesis x minus x1. The negative 1 and the 2 are the x1 and the y1. And you notice they give us the m. So let's make substitutions. For y1, fill in 2. For m, fill in 3. For x1, fill in negative 1. Here's an equation of the line, but it's not in the form ax plus by equals c. Let's do the distributive property. Y minus 2 equals 3 times x is 3x. The negative of the negative 1 is really a plus 1. When you times that by 3, we get positive 3. Next, let's subtract 3x from both sides. We get negative 3x plus y minus 2 is equal to 3. Now add 2 to both sides. Negative 3x plus y is equal to 5. Finally, make a positive leading coefficient by dividing everything by negative 1. 3x minus y equals negative 5. Every dot on this graph is a solution for x and y in that equation. Number 7, let's graph this and then create the equation. The point 0, 0 is the origin. If m equals 1 and you think of that as a ratio, that's 1 over 1. A rise of 1 and a run of 1. Another dot's right there. And draw a line through the dots. Now let's create the equation for this line. We have a point and we know the slope. So we're going to use point slope form. Y minus y1, which is a 0, equals m times x minus x1, which is a 0. Let's simplify this until we get that ax plus by equals c form. Y minus 0 is really just y. 1 times x minus 0 is really just x. Now let's subtract x from both sides. We get negative x plus y is equal to 0. Then divide everything by negative 1. X minus y is equal to 0. Number 19. This time we're given 2 points. From 2 points you can make the graph of a line. Let's graph the first point. 1, 2, 3, 1, 2, 3. Here's negative 3, comma negative 3. Now let's graph the second point. Left 1, up 2. And draw a line through the 2 dots. Now let's get our equation. This time we're not given a point and the slope. But from 2 points we can find the slope using the slope formula. M equals y2 minus y1 over x2 minus x1. Let's identify the 4 variables, x1 and y1, x2 and y2. So y2 is 2 and y1 is negative 3. x2 is negative 1 and x1 is negative 3. 2 minus negative 3 is 5. Negative 1 minus negative 3 is 2. Now we know the value of m. We've made this problem be just like the other ones, where we have a point and we have the slope. Let's use point slope form. Again, the formula is y minus y1 equals m times x minus x1. Let's fill in our y1. It's negative 3. Fill in our m. That's the 5 halves. Fill in the x1. That was negative 3. Now we need to change this equation to the ax plus by equals c form. On the left side, the minus negative can be written as a plus sign. On the right side, let's do the distributive property. 5 halves times x is 5 halves x. The negative of negative 3 is really a plus 3. When you multiply 5 halves to 3, you get 15 halves. Next, I'm going to multiply everything by 2 to remove the denominators. 2y plus 6 equals 5x plus 15. Now subtract 5x from both sides. Negative 5x plus 2y plus 6 is equal to 15. Now subtract 6 from both sides. Negative 5x plus 2y is equal to 9. Finally, let's make a positive leading coefficient. 5x minus 2y is equal to negative 9. Number 29. We're asked to create an equation for a line that goes through this point and is parallel to the line given by this equation. Parallel lines have the same slope. So what is the slope of this one? Well, this is a special case. The equation has no y term, it only has x. This is a special case of a vertical line that crosses the x-axis at negative 2. A vertical line has no slope. All vertical lines will have this format for their equation. So to create our equation, we're going to follow that format. X equals, and then look to see what x equals. It's negative 5. There's the equation of our line. Now page 89, number 2. Graph a line through these two ordered pairs and find its slope. 6, 1 is located here. 10, 3 is located here. And draw a line through the dots. To find the slope, we want to count rise and run. Start at this dot and travel to this dot. How many units are you rising? You're going from a 1 up to a 3. That's 2 units. How many units are you running to the right? We're going from a 6 over to a 10. That's 4 units. So m is equal to a rise of 2 over a run of 4. And this reduces to a half. We're asked to redo this and use the slope formula. The slope formula is m equals y2 minus y1 over x2 minus x1. Let's make our substitutions. 3 minus 1 and 10 minus 6. That's 2 over 4, or a half. You probably noticed that using the slope formula is really the same thing as having a picture and counting the rise and the run. Number 14, graph a line through -3, 0 with m equals -2. Let's find -3, 0. It's located here. Now think of the slope as a ratio, -2 over 1. The top number's the rise, the bottom number's the run. But because the top number's negative, we're not going to rise, we're going to go downwards. From the dot, go down 2 units and run 1 unit to the right. We could do this again for more accuracy. Down 2 and run 1 to the right. And draw a line through the dots. Number 20, we're given ordered pairs and asked, do the points line up in a straight line? If they do, there will be a constant rate of change between the points. So let's find the rate of change. X is changing by 1 unit when Y changes by 2 units. If we create a rate, the Y changed by 2 when the X changed by 1. Let's compare these. The X changed by 1 and the Y changed by 2. So that's the rate, 2 over 1. Let's compare from here to here. That changes by 1 and that changes by 2. So that's the rate, 2 over 1. We got the same rate every time, so the answer is yes. These points line up in a straight line. And we found that the slope was 2 over 1, or simply 2. Next, number 28, we're given an equation and asked for the slope. It will be easier if we change this equation into slope-intercept form. So let's solve it for y. Subtract 5x from both sides. We get -2y equals -5x plus 6. Now divide by -2. We get y equals -5x over -2 plus 6 over -2. Let's simplify this. This makes 5 over 2x minus 3. The slope is 5 over 2. Because the slope is the number in front of x when you have this format. The y-intercept is -3, because the y-intercept is the constant term when you have this format. Now we're going to graph it. Start by graphing the y-intercept. There's a dot at -3. Now use the slope as rise over run. Let's put a few more marks on there so that we can count the rise over run. 1, 2, 3, 4, 5, 1, 2. And draw a line through the dots. Now page 84. Graph y minus 8 equals 0. Let's solve that for y. And then graph that special case equation. It crosses the y-axis at 8. And it is a horizontal line. Now number 9, let's solve this for x and graph this special case equation. It crosses the x-axis at -1, and it's a vertical line. Number 32, solve for k so that -2, -1 is a solution to the equation. This is its x-coordinate, this is its y-coordinate. Let's make those substitutions. For the letter y, fill in -1. For the letter x, fill in -2. And solve the equation. Let's add 3 to both sides. And then divide by -2. Next, page 79, number 8. Find 3 roots if we use integers as our domain. Let's simplify this first to make it easier to find roots. Negative of -4 is +4. Negative of -x is +x. Now let's subtract x from both sides. Then subtract 4 from both sides. Now the equation has the letter y alone, and that'll help us to find roots. We could organize them in an xy table. We're told we can use integers for x, so 0 is an integer. 4 times 0 minus 12 makes -12. One of our roots is 0, -12. Another integer is 1. 4 times 1 minus 12 is -8. So another root is 1, -8. Let's use 2 for x. 4 times 2 is 8. Take away 12 is -4. So this root is 2, -4. We have found 3 roots. Number 14, let's find at least 3 roots for this one. And we're told to use real numbers for our domain. Let's solve this one for y as well. That worked pretty good last time. And use an xy table to organize our solutions. 0 is a real number that's usually pretty good to do math with. So we get y is greater than or equal to 5 minus 3 times 0. But this is just the same thing as y is greater than or equal to 5. From this one row, we have all kinds of roots. When x is 0, y could be 5. When x is 0, y could be 6. When x is 0, y could be 6.1. Y can be anything greater than or equal to 5 when x is 0. So here's 3 roots, and we didn't even try other numbers for x yet.